Yeah. So, hello, my name is Stefan Thies. I work as DevOps evangelist at Zematext. We build monitoring and logging solutions. In addition, we are well known for consulting for big data, Elasticsearch, Solar, and Kafka. So this talk is about performance metrics in Node.js. But on the Meetup, I would like to share more the experience developing a Node.js monitor than going only through the metrics and telling you what it means or what is useful there. For the second part, with the metrics, I will show you examples from real life Node.js application that we run and monitor. So when you collect metrics in wherever you collect it, you have to aggregate metrics. A lot of people think, okay, there is a CPU average or something, I store it somewhere and later on I will visualize it. Actually, what you have to do, you have to aggregate it over time because you like to see what was the average over 1 minute, what was the average in 10 minutes, or what was the total over some time. A running monitoring agent looks, for example, what is the current memory, and or in case of garbage collection event, we might have 50 events per second where garbage collection is triggered. And so we have to calculate then the sum and average in this minute. Zematext is running a backend to collect metrics. We're running their Java technology, Hadoop, to aggregate the metrics so we can make queries over hours, days, weeks, even I can show you charts over several months, which are rendered very quickly because we do this aggregation in the backend. Normally, if you just store your numbers and you have 50 data points per second, and this for many services, and you try to render a chart that builds the average in a graph in the user interface, it will not work. So that's why we need aggregation. And in Node.js, I was looking for a library that can do the aggregation in the client. And I used here the measured library. It's a part of the Coda Hales metrics library. So this is very handy to calculate the sum, average, min, max, and also percentiles of the different metrics. The second library that we use here is NeDB. It's a JavaScript-only database. I was looking mainly for libraries. I don't know how you select Node.js packages. Typically, I evaluate them and see how useful they are, how is the feedback on GitHub, and what is the performance of it. And good criteria for me is also if it has no native binding, as this makes always a trouble, mainly for Windows users that have to compile it. On Linux is less a problem. There's everywhere a C++ compiler available. So this has no native binding, and it was good to store metrics in case that we lose the network connection. So if you use, for example, StatsD for monitoring, you might know it, it's using UDP, and it fires out the metrics to StatsD server, and if you lose network connection or there's any problem, you lose your metrics. Typically, you look into performance problems right at the moment when something goes wrong. You see something is not working, maybe the network was one of the issues, and that same moment you lose the metrics. So this is something that we try to avoid. What we do is when we lose the connection to the backend, we store the metrics in a local database, and when we get connected back to the metrics backend, we can forward all the data to it. So it's not really store and forward, we store only in case when something fails. And this model, I must say, we never had a problem with it. There's one rare case when you manage to start the monitor twice, which usually doesn't happen. Another interesting experience, Zematext is a company working with Java technology. I'm kind of a Node.js island there. And the two tools work completely different. At least if you have traditional Java servers, there are, let's say, new and modern technologies that work event-driven also in Java. But what you typically face is that you have an async I/O operation to a HTTP server. This means our first three function calls. I don't know if you can see the mouse if I use that. No. So the first three function calls are done within a few milliseconds, and it hits the Java server. What happens there? It starts a new thread to handle this request. So if we hit many requests to Java server, it's starting many threads. And if you have some limit there, typically there are limits like 100 in production. In this example, it's just 3, so the fourth request fails because Java cannot start another thread to give you an answer. And again, making an HTTP request is really fast, like a function call in Node.js. It's not blocking. And if you do a loop to send your metrics to a backend, you hit very fast the limits. So this is something I learned the hard way. So I learned, say, loop, be nice to Duke. I killed already a few Elasticsearch servers in the past. And with the Node.js monitoring, I had another issue. You spend a lot of time in unit testing, and especially for the task to collect metrics, store the metrics, and forward it. There are several test cases. Like first you run, you see you get your metrics, then you simulate a situation where it fails. You collect the metrics into your local database, and when it comes back, you ship them all to the backend. Easy tests. When I run it in production condition, normally we ship the metrics every 1 minute. So a lot of time. Running such a test took me then 8 minutes or so. And yeah, time is money. And I thought, I'm smart. I can do this better. I do this in 30 seconds. I tune the collection interval to a few milliseconds. I tune the transmission interval to a few milliseconds. And the test should go very quickly. One thing was really wrong, and I used the setting to use the production servers. I thought integration test is good with production servers. When it runs with the production servers, it will be fine, and every customer will be happy with it. And one day, then I integrated it to Travis, and I got this nice message in Skype from a colleague, some stupid guy called Travis running denial of service attacks against the backend. So I killed one of our receivers. The best day in my company, I thought, okay, that's it. First time I worked for them and made a good job. And now I can leave because I killed the backend. It was not the case. So the Java guys were very friendly to me. They said, okay, this was a good case that our backend got overloaded. How can we improve it? How can we protect the service from the denial of service attacks, how they call it? And introduced also event-driven communication with the receivers in general. It improved the service, but on this day I was not feeling very well. You can believe. So another challenge I faced during the development of the Node.js monitor was, Node.js runs on many platforms, but this means it is not very good in providing platform-specific metrics because the general function calls have to be available everywhere. It's similar to Java. If you look what operating system metrics you can get from Java, from the standard library, is only the common level. What is free memory doesn't tell you anything on Linux because there is no buffered memory information, and the most free available memory in Linux is buffered memory. For the CPU, we didn't have all information. There was no information. I don't know, there's no standard API in Node.js as far as I know that gets any disk I/O details. So in this case, there's a nice library that reads from the Linux /proc file system, and you can get every metric very detailed from there. So very handy, it's very stable because the /proc file system in Linux is stable, very good to use. The next issue is when you have developed the Node.js monitor, it has to run in process, and the question is, how to inject it in a process. In Java, you have maybe a JMX interface where you can connect remotely, and there's the possibility to expose metrics via JMX. Node.js is not in the stage that it has such a standard inside. Okay, so what we do is we require the agent in the source code, but this is something ops people are not happy with, so they get an app, they deploy it to some platform, and then it's hard to change a single line of code. So it has to be the first line of code because it adds instrumentation for different classes, like it adds hooks to HTTP, function to measure the HTTP throughput. And there was, since I think IO.js 1.6, there was a new function in Node.js where you can require a module before the Node.js program starts itself. So this is very nice. You can start Node -r and specify the module you like to load, and then you load your actual program. Very cool feature in Node 4. The most important metric, I will talk a lot about it today, is garbage collection in Node.js, but I'm still on the issues I had with developing the Node.js monitor. Well, how does it work? Basically, it makes some incremental garbage collection once, and then it marks what needs to be deleted, and later on, it deletes it. The marking process stops your Node.js process. And I can show you later on very nice numbers where programs slept 10 seconds in 1 minute. So that's a lot of time you might lose in garbage collection. The second cycle, what I call here full garbage collection cycle, looks again into objects which have survived the incremental garbage collection. And so it can look to more complex structures and clean those. So the question was, what should we measure? What we could get from open source libraries was like a count of garbage collection cycles. We could calculate the garbage collection cycles per time, like having a rate, like 20 garbage collections per second, per minute, whatever. We could make a sum of all the garbage collection time. I think that's a very interesting metric to see. Really 10 seconds in 1 minute was spent in garbage collection. And we could measure the released memory, having it before and after garbage collection. Looking into libraries, or just first, how can I get the information in the Node.js command line? If you look to Node and started with the V8 options, it shows you all the options you can pass to the Node.js V8 engine, the Google V8 JavaScript engine. And so many options, so you can search for it for _DC and you get the garbage collection options. A typical option is to use trace GC, and there's also some other that give you more details, and you get the garbage collection information to the console. But there's no other way. So there's no option to store it to a log file or pipe it to a different stream. It's very hard to work with it. Even on my MacBook, I couldn't catch the output stream and write it to a log file. And it's in real time, so it goes very fast and hard to read. Okay, you take a library. I have 3 libraries here. It's a GC Stats, it's a GC Profiler, and MemWatch. MemWatch is missing some metrics. There were some I requested to add them there. It has some leak detection and it can make a heap diff. This is nice on the MemWatch library. And GC Stats provide exactly what I mentioned before, like number of GC cycles and the time consumed in garbage collection. Those are native libraries. This means it needs to be compiled when you install it with npm. And you see how important native packages are to Node.js. It's based on a Node it's called Native Abstraction for Node. And there are only 857 packages, depending. Means these are native modules in Node.js. And with the 6.5 million downloads, and rank 95 in the NPM registry, which is really high. So a lot of Node.js applications depend from this native interface. And this is one issue I had when developing it. It was in a phase where IO.js separated from Node.js. They integrated a new V8 engine. At the same time, the native abstraction layer was broken. This was really a bad time in Node.js. Yeah, moving forward with the new project, or staying with the old code, 0.10, 0.12, or moving forward. We had the opinion IO.js will be the new Node, and this is what actually happened. IO.js is today Node.js 4. And nevertheless, this was a quite unstable time. And so there was then talks on GitHub, like, typical situation. Sorry. Typical situation was here, it's not installing on IO.js, on different IO.js versions. Then other problems like compile problems on Windows, or we should provide pre-compiled versions of it. Today the situation is fine, so those projects moved to Node abstraction layer version 2, and it compiles on Node.js 4, and it compiles on Node.js 0.12, for example. I have some hope that the garbage collection insights get into the Node.js project itself. There is an issue on GitHub to implement it. They have all the information. They can put it to the console. Why not providing an API to the V8 to measure the garbage collection directly in Node.js? And it would solve all the problems people have that like to have garbage collection monitoring, like the installation on Windows with the complex compile procedure. On Windows, you have to know when you install a native module, you have to run the Visual Studio and have to have the right setup for your compiler, which is one command line on Linux only. So I hope for this. Some examples. In general, when people think about monitoring, they think about server monitoring. What is my CPU? What is my memory? Disk I/O, very traditional monitoring. What we need actually for Node.js applications is we need process metrics and application-specific metrics, technology-specific metrics to see what happens inside of a Node.js application. So it has to run as in-process monitor, as I mentioned before, and it needs to either be embedded in the source code or started with the require for the module that I showed before. So what you get in traditional Node.js, in traditional process monitoring, you might see the upper orange line, which is the total memory of a process. And if you embed the monitor into the Node.js process, you might get insights like the heap used and the total heap used in Node.js that you can get from a simple function call of the OS class with free mem and total mem, things like that. If we look to garbage collection, this is just a chart showing two different processes. So we have a blue process and a yellow one, and you see the little green maybe. Just let me check. So the little green is the full garbage collection ones, and the little orange and the incremental garbage collection ones are the yellow and the blues. So if everything is normal, typically you have these cycles, less than 50 cycles per minute. It's under 20 milliseconds. And the released memory depends, of course, of your application, but basically this application is doing nothing. It's regular level. Sorry. Magnifier, okay. What we do in real life is we run Kibana. If you don't know Kibana, it's a dashboarding tool for Elasticsearch. It has a bit of history. It was a Ruby server, then it was an HTML5 application, and they moved to Node.js with the Express framework, and this is the version we use today in production. We will move this week to the new one, which moved to another framework. And So we run this managed elk stack, and we have the problem that Kibana is essential for many users because everybody likes dashboards, and we have to keep it running. So what we have in production needs to be monitored. General rule. Well, if you look, Christmas was still running, but a week after, as I came back to work, Kibana took all the memory, and another web service running on the same machine could not allocate memory, so we had also to kill Kibana. The little other curve behind, see just the restart, and then, okay, we touch the system, what do? We update then to latest Node.js, and we put some memory options inside, and this tamed a bit the memory leak which exists in this Kibana version in 4.1. Nevertheless, the chart looks much better, and it was working again. You see at the end, it's now running more than 4 weeks. At the end, it starts again and makes a little bit of trouble, but we upgrade soon to the new version, and I hope we have success with that. And there's also a new issue on GitHub already that the new Kibana version has similar behavior, not reproducible by Elasticsearch, but several guys are reporting seeing similar things with the new version. So I hope it will be better with the next version. But Node.js monitoring made it visible to us that there is a problem. We are able to report it, and we hope we get then a better version. That's really a situation where you are not owner of the application. You cannot go and change everything inside. If it's your own application, you can tune it, you can fix the errors. But if you run a third-party Node.js application, it becomes really a problem, and you have to see what's going on there. So what happened to the event loop? This is regular event loop, 400 microseconds, 500 the delay here. This jumped a bit up, so we got 3 to 15 milliseconds at the same time where the garbage collector got crazy and was doing nothing else than running garbage collection cycles. And if you're new to Node.js, you might not know, but the general rule is don't block the event queue. So don't code like this one, putting a timer and making them sync operations, sync IO operations. This blocks your event loop, and in the monitoring you can see it very nicely, having one point with a high latency there when such a sync operation happens somewhere in the event loop. Process monitoring, this is a healthy sawtooth. So you see memory goes up, garbage collection kicks in, memory goes down. Very fine. It has one level, so we don't cross the 95 megabytes here. There is no memory leak. This looks really fine. It's captured by process doing nothing, basically. This is again the real world example from Kibana back to September. In September, I see there's something wrong in the chart. It should be September 2015, October. Oh no, it's just a date. It's the 16th September where we started. We have a few restarts where we see where the memory goes down and up again. Maybe some updates we made at the beginning, and then we said, okay, that's stable, and it's now running until these things happened beginning of January, where it simply took too much memory. So this is really worth to put alerts on when you have when you see that your memory is growing all the time. And this is something, if you would look every day to your monitoring system, you see it's 95 megabyte as usual. Next day you look, it's 100 like usual. But then one day you think, a few weeks ago it was something like 80. This is something you doesn't feel when you look every day to it. And if you have long-term monitoring, you see really what is going on You don't see a very little memory leak very quickly. It can run several weeks until something gets crazy and takes off. Well, another thing that we measure in the monitoring is the number of workers. All familiar with workers in Node.js? So it's called cluster API. What you do is you have one master process, and with Node.js you cannot get 100% CPU on a multi-core machine because Node.js is CPU bound. If you start one process, give it 100% load, you use one CPU core. To use them all, and today we have all multi-core machines, we have to start multiple processes. And what the cluster API is doing for us, you can start multiple processes and you can share the sockets. Means in this example, this is quite an example from the Node.js API documentation. Basically, if it's master, then it forks. In this case, the CPU has 4 cores, 4 processes. And if it's not the master, then it starts to the web server. If one of the sub-processes gets closed, either it killed itself or it got killed for other reasons, out of memory, whatever, it simply starts a new process. So we should have always 4 workers running. You might use this API in a different way when you implement, for example, message queues, and then you decide I get a specific load on my message queue, I fire up another process to work on the tasks. So in that case, you might start dynamically multiple workers and not in a static setup like we do it here for the web server, which should use all cores. And so this is then a very simple graph that we get. We see how many workers do we have running. And this is, let's say, a simple indication how is my Node.js application doing? Are all the processes there which should be there? Gets then interesting when you like to correlate, especially when you use workers for batch jobs or something, to see how much resources are consumed with different workers. We have done such filters where you can select the process ID and we named them simply 0, what is master, and on the other has a serial number for each worker, so you can identify it also when the complete process got killed and started again. 0 is my master, and the other got a serial number, how they did start. Node.js is a lot used for web services. So what we did here, we made hooks into the HTTP server functions. And so we can measure every HTTP call and get then metrics for the response time of web services. We can then create a request rate, and we can also measure the response size of every HTTP request. This works with all the frameworks because we are directly based on the Node.js HTTP API. I hope you don't see, I like very much these blue bubbles. I hope you don't see it. In this case, it was coming also from calls blocking the event queue, like checking if a file is there, or loading some files, static files from the disk with read sync, things like that. Yeah, make these bubbles in the chart. If you have to generate it, it's good to know. In normal case, the bubbles should be more like the regular latency in your web service. Beside of that, it's useful to measure the HTTP error rate. So how often do we have errors in our request? If you run an API service and somebody calls the API wrong, you return a message code 500 or something. And then it's good to see how many errors do we have over time. It's a good indication to see if the service operates on regular level or not. Another good criteria to put alerts on it. And having an error breakdown where you could look at different HTTP errors. So these are common things you can do when you monitor the HTTP API interface. And getting to the end, if you have the full picture of it, the then you see really what happens in your application. You see here the CPU was doing nothing, memory exploded, garbage collection got crazy, and we had some really slow requests in the web service, one are taking 4 minutes to answer to requests. And you can do even more if you put your dashboard together with related applications, like if you have then the Elasticsearch monitoring with Kibana, or MongoDB monitoring with the Node.js monitoring. You see then also where is it coming from. If you see the latency in HTTP requests, you might also see your latency in the database requests in Parallel. I think that's it, what I wanted to show you today. And yeah, if you like it, follow me. There are my NPM packages on the NPM registry, also the packages from Zematex. And you can follow us on Twitter if you like. Thank you. Any questions? No, everybody's monitoring Node.js already. You know all the tools.
Maybe one question, or first one thing to note. On those blocking API calls you mentioned, I think someone's brought out a package recently, might have even been somebody from the code team, that will send messages or alerts if anybody or your libraries are using the sync calls. So you can get, if you're unsure whether that's happening somewhere in your code, there's a library out there somewhere that'll help you detect that. And my question would be, what frequency do you choose for the logging? Do you do that every second, every 10 seconds? Do you use sort of the snapshots? Do you use with averages? For example, if you monitor RAM usage only every 10 seconds, theoretically you might miss a spike, things like that.
Basically, this is configurable in the agent. So you can set the collection interval, how often it should collect and how often it should transmit data. I would say the regular cases or default settings are doing collection every 10 seconds and transmitting every minute, because we have here monitoring for systems running a long time in production, and we have to cover the metrics for a long time. That's why the settings are that way. It's not like real time, what happens in the last second. I made one function call and CPU jumped up. The resolution is 1 minute, basically. More questions? Okay, then thank you very much. You can catch me with a beer in hand and we can talk. Thank you.
All right, well, that's it, everyone. We actually managed to get 3/4 of everything live streamed with audio. So that's 75% successful. Maybe even better next time. So yeah, thank you all so much for coming out. The next meetup is going to be in April. I hope to announce the date more shortly. We already have speakers and so forth lined up, so that's all cool. Thanks for those coming out, and thanks to those in the live stream as well. Feel free to stay around here for another half hour or longer. Drinks are still here, people are still here, and enjoy your evening. Thanks.